Welcome and relax. Take a moment to settle in, breathe deeply, and let your mind drift. Feel the quiet around you, the gentle rhythm of your thoughts, and the calm that surrounds this moment. Listen and simply be. Before clocks, before calendars, before seconds, minutes, or hours, time still existed. But humans didn't count it the way we do now. They felt it. Long before gears, pendulums, or ticking hands, time was something observed through the body, the sky, and the land itself. It was not precise, it was not exact, and it did not need to be. For early humans, time was not a measurement, it was a rhythm. The rising and setting of the sun marked the most basic cycle of all. Light meant safety, work, and movement. Darkness meant rest, danger, and stories told around fire. There was no question of what time it was. There was only whether the sun was here or not. Morning was when the light returned. Night was when it disappeared. And that was enough. Early hunter-gatherers lived in deep connection with their environment. Their survival depended on noticing patterns, not minutes. They watched shadows stretch and shrink. They observed the changing angle of the sun. They listened to birds, insects, and animals whose behaviors followed invisible schedules written by nature. Time was not something external. It was something lived. A hunt did not last 2 hours. It lasted until success or failure. A journey was not 20 kilometers long. It took as long as the body could endure. Even sleep followed instinct rather than schedule. People slept when tired, woke with light, and rested when darkness returned. The body itself was the clock. As humans began to settle into early communities, time slowly became more important, not as a concept, but as a shared understanding. Farming changed everything. Once humans began to plant crops, time was no longer just about today or tonight. It became about seasons, about patience, about waiting. Seeds planted too early would die. Seeds planted too late would never grow. So people started paying closer attention to the sky. They noticed how the sun's path shifted throughout the year. They noticed longer days and shorter nights. They noticed the way certain stars appeared only at specific times. Slowly, patterns emerged. Spring was the time of planting, summer was the time of growth, autumn was the time of harvest, winter was the time of survival. These were not abstract divisions, they were life and death. The year itself became a kind of clock, one that ticked slowly, measured not in seconds, but in moons and harvests. The moon played a powerful role in early timekeeping. Unlike the sun, the moon changed visibly night after night. It grew, it shrank, it disappeared, and then it returned. This repeating cycle became one of the earliest ways humans tracked longer periods of time. A full moon meant visibility at night. A new moon meant darkness. People began counting nights between moon phases. This is where the concept of the month was born, not as a number, but as a cycle. Many early cultures measured time by saying things like 3 moons ago, after the next full moon, or when the moon returns. The moon became a silent calendar in the sky. But days themselves were still fluid. There were no hours, no minutes, no fixed divisions. Instead, the day was divided by natural events: dawn, midday, dusk, night. These were not exact moments, they were transitions, gradual changes that everyone could see and agree upon without argument. If someone said, "We leave at dawn," no one asked which minute. Everyone knew what it meant. As villages grew larger, shared time became more important. People needed to coordinate work, rituals, gatherings, and rest. This is when humans began marking time not just by observation, but by symbols. Shadows became tools. A stick placed in the ground would cast a shadow that moved throughout the day. People noticed that the shadow's length and direction changed predictably. This simple observation led to one of the earliest time-measuring devices, the sundial. At first, it wasn't precise. It didn't tell time in hours. It simply told before and after, morning or afternoon, approaching noon or leaving it behind. But even this was a massive shift. For the first time, time could be seen without watching the sky itself. It could be marked, shared, compared. Still, time remained deeply tied to nature. On cloudy days, the sundial was useless. At night, it told nothing, which meant humans still relied on their senses, memory, and environment. In these early stages, time was not something you chased. There were no deadlines, no alarms, no pressure to be somewhere at an exact moment. Life flowed at the speed of seasons, bodies, and daylight. And perhaps most importantly, time belonged to everyone equally. No one controlled it, no one sold it, no one felt they were running out of it. It simply passed, quietly, endlessly, as it always had. As human societies grew more complex, time slowly stopped being just a natural rhythm and began to take on meaning. Not just when things happened, but why they happened at certain moments. This shift was most visible in early civilizations where time became deeply tied to religion, power, and the heavens. Ancient people believed the sky was not empty, it was alive, filled with gods, spirits, and forces that controlled the world below. If time could be understood, then perhaps those forces could be understood too. So humans began to study the sky with intention. The sun was no longer just light. The moon was no longer just a guide. The stars were no longer decoration. They became tools. In ancient Egypt, time was sacred. The Nile River flooded every year, bringing life to the land. This flooding happened with remarkable regularity, and the Egyptians noticed it coincided with the rising of a particular star, Sirius. When Sirius appeared just before sunrise, the floods were coming. This moment became one of the most important markers of time in Egyptian civilization. It didn't just signal a season, it signaled renewal, rebirth, and divine order. Egyptians divided the year based on this cycle, not with numbers, but with meaning. There was the season of flooding, the season of planting, and the season of harvest. Time was inseparable from survival and spirituality. To track the passing of days, Egyptians refined the sundial. They also developed shadow clocks, stone or wooden devices that marked the sun's movement more consistently. Eventually, they divided daylight into parts. Not hours as we know them today, but segments that helped organize labor, rituals, and prayer. Still, time was flexible. Daytime hours in summer were longer than daytime hours in winter. The hour itself changed length depending on the season. Precision did not matter, order did. Meanwhile, in Mesopotamia, the land between the rivers, time took a more mathematical turn. The Sumerians observed the sky obsessively. They tracked the movement of planets, stars, and the moon with astonishing care. Over time, they developed numerical systems to describe what they saw. This is where something familiar was born: the number 60. The Sumerians used a base 60 counting system, and from it came divisions that still shape our lives today: 60 seconds, 60 minutes, 360 degrees in a circle. But originally, these were not about seconds ticking away. They were about dividing the sky. The circle of the heavens was split into manageable parts. Time was mapped onto space. Night after night, priests and astronomers recorded celestial movements. They predicted eclipses. They charted planetary paths. And in doing so, they turned time into something measurable, something repeatable. Yet even here, time was not neutral. It was controlled by elites, by priests, by those who could read the sky. Knowing time meant knowing the will of the gods. In ancient China, time was also deeply symbolic. The Chinese calendar was lunar, but carefully adjusted to match the solar year. Months followed the moon, years followed the sun. This delicate balance required constant observation and correction. Timekeeping was a matter of state importance. The emperor's legitimacy depended on harmony between heaven and earth. If the calendar was wrong, if eclipses went unpredicted, it was seen as a sign of cosmic disorder. Time, in this sense, was political. To track it, ancient Chinese astronomers used instruments like gnomons, tall vertical rods that measured shadow length. From these shadows, they could determine solstices, equinoxes, and seasonal changes. They also used water clocks. A steady flow of water dripping from one vessel to another allowed time to be measured even at night or during cloudy days. The sound of water itself became a marker of passing moments. But water clocks were imperfect. Temperature changed the flow. Evaporation altered timing. No two clocks behaved exactly the same. Still, they represented something new. Time no longer depended entirely on the sky. It could be contained. In ancient Greece, time began to split into two ideas. There was chronos, measurable, sequential time, and kairos, the right moment, the meaningful moment. Chronos could be tracked with sundials and water clocks. Kairos could not. It was felt. Greek philosophers debated the nature of time endlessly. Was it a thing, a movement, an illusion created by the mind? Aristotle believed time was tied to change, that without movement, time could not exist. Others argued it flowed independently, whether humans noticed it or not. Public water clocks were installed in Greek cities to regulate speeches, court cases, and debates. When the water ran out, your time was up. For the first time, time limited speech. It controlled behavior. It began to feel external. Yet despite all this progress, time was still uneven, still approximate, still shaped by nature, belief, and human interpretation. No two civilizations measured it the same way, and no one yet lived by the second hand. For most of human history, time lived above us. It rose with the sun. It faded with the stars. It changed with the seasons. But slowly, something shifted. Humans began to imagine time not as a celestial rhythm, but as a system, something that could be carried, transported, and controlled even when the sky was hidden. This shift did not happen overnight. It happened through patience, failure, and clever observation. The first major step away from the sky came with one simple idea. If something flows at a steady rate, it can mark time. Water became the answer. Water clocks, known as clepsydra, appeared independently in multiple civilizations: Egypt, Mesopotamia, China, Greece, and India. Different cultures, same intuition. Water moves, and it keeps moving. A basic water clock was simple: a container with a small hole. Water dripped out at a roughly constant speed. Marks on the container showed how much time had passed. No sun required, no stars required, just gravity. For the first time, humans could measure time indoors, at night, and during storms. But this freedom came with problems. Water does not behave perfectly. Cold slows it down. Heat speeds it up. Sediment clogs the holes. So civilizations refined the design. Some water clocks filled instead of drained. Others used float mechanisms connected to gears or indicators. In China, complex water clocks powered rotating wheels, bells, and figurines that announced the passing of time. These weren't just tools, they were spectacles. Time became something you could watch. In ancient courts and temples, water clocks symbolized knowledge and authority. If you controlled time, you controlled order. But water had limits. It froze, it evaporated, it leaked. So humans looked for something else. They turned to fire. Candle clocks were used in China, Japan, and medieval Europe. A candle marked with lines would burn at a relatively predictable rate. As the flame reached each mark, time passed. Some candles had small metal balls embedded at intervals. When the wax melted, the balls fell into a tray below, making a sound. Time could now be heard. Incense clocks went even further. Specially shaped incense sticks burned slowly, releasing scent as they went. In monasteries and homes, smell became a clock. A room filled with fragrance signaled that a certain amount of time had passed. These clocks weren't precise, but they were deeply human. They engaged sight, sound, smell. Time was no longer abstract, it was sensory. Still, none of these methods created a universal standard. An hour in one place was not the same as an hour in another. Time remained local, personal, cultural. The breakthrough came not from better materials, but from a new way of thinking. Instead of tracking natural processes, humans began imagining time as something that could be divided into equal parts, even if nature didn't cooperate. This idea matured during the Middle Ages. Monasteries needed structure. Monks prayed at fixed times throughout the day and night. Relying on the sun or water was unreliable. They needed consistency. This pressure gave rise to early mechanical timekeeping. The earliest mechanical clocks appeared in Europe around the late 13th century. They were massive, heavy, and wildly inaccurate by modern standards. But they did something revolutionary. They ticked. Using weights, gears, and escapement mechanisms, these clocks created repeated, controlled motion. Time no longer flowed, it stepped forward. Tick, tick, tick. Each tick represented an equal unit. For the first time, time was chopped into identical pieces. No seasons, no sky, no judgment, just motion. These clocks weren't meant for individuals. They were installed in towers, public spaces, churches. They rang bells to mark the hours, calling people to prayer, work, or rest. Time began telling humans what to do instead of the other way around. Life slowly reorganized itself. Markets opened at certain hours. Workdays became structured. Night gained meaning. But early mechanical clocks drifted constantly. They gained time, lost time, required daily adjustments. Still, something irreversible had happened. Time was no longer alive. It was mechanical. And once time became mechanical, it could be improved, refined, optimized. Once time began to tick, humans became obsessed with one thing: precision. Early mechanical clocks worked, but poorly. Some lost 15 minutes a day, others gained time unpredictably. Two clocks in the same city rarely agreed. At first, this didn't matter much. Hours were still loose concepts. Life moved slowly. Few people needed exact synchronization. But the world was changing. Trade expanded, cities grew, travel increased, navigation became critical. Time could no longer be approximate, especially at sea. Sailors faced a terrifying problem. They could calculate latitude using the sun and stars, but longitude remained elusive. Without knowing longitude, ships drifted off course, missed land, or vanished entirely. The solution required knowing the exact time back home while sailing across the ocean. Timekeeping suddenly meant survival. This challenge ignited one of history's most intense technological races. In 1714, the British government offered a massive reward for anyone who could solve the longitude problem. Many tried, most failed. Clocks were too sensitive. Humidity warped wood, temperature expanded metal, constant motion disrupted gears. But one man refused to accept failure. John Harrison, a self-taught clockmaker, devoted his life to this problem. Over decades, he built a series of increasingly sophisticated timekeepers designed specifically for ships. He invented temperature-compensating springs, friction-reducing mechanisms, balanced systems that resisted motion. After years of testing, his final design worked: a clock that could survive the ocean. With Harrison's marine chronometer, sailors could finally calculate longitude accurately. Ships stopped disappearing. Empires expanded more confidently. Global trade accelerated. Time had conquered the sea. Back on land, accuracy continued to improve. Pendulum clocks, introduced in the 17th century, dramatically increased precision. A swinging pendulum provided a regular, predictable motion, far more stable than earlier mechanisms. Minutes became meaningful, seconds became measurable. Time was shrinking. But precision had a strange side effect. As clocks became more accurate, humans became more anxious. Being late was no longer acceptable. Schedules tightened. Work hours became enforced. Factories demanded synchronization. Workers had to arrive at exact times. Bells and whistles replaced sunrise and sunset. Time stopped adapting to humans. Humans adapted to time. This shift reshaped psychology. Days were no longer organic flows, they were sequences. Tasks were broken into units, productivity became measurable. The clock didn't just measure life, it structured it. By the 18th and 19th centuries, cities ran on time. Trains required precise schedules to avoid collisions. A minute of error could be deadly. But here, a new problem emerged. Local time differed from place to place. Noon in one town wasn't noon in the next. With railways stretching across countries, chaos followed. Trains missed connections, timetables failed, accidents occurred. The solution was radical: time zones. In the late 19th century, standardized time zones were adopted. The world was divided into sections, each agreeing on the same time. For the first time in history, time became global. Local solar time, humanity's original clock, was officially abandoned. The sun lost authority. The clock ruled. This transformation was quiet but profound. People no longer lived by the sky above their heads, but by invisible lines drawn across maps. Time was no longer experienced, it was imposed. And still, the pursuit of accuracy didn't stop. By the late 19th century, clocks were everywhere. Church towers, train stations, factories, homes. Time surrounded people. Yet something strange happened. The better clocks became, the less time resembled anything natural. Early timekeeping had always been visible, shadows moving, water dripping, sand falling. You could see time passing. Now, time hid inside boxes. Ticking gears, unseen oscillations, silent precision, and soon even gears would disappear. The breakthrough came from an unexpected place: vibrations. Scientists discovered that certain objects vibrated at extremely stable frequencies. If those vibrations could be counted, time could be measured with unprecedented accuracy. One material stood out: quartz. When electricity passed through quartz crystals, they vibrated at a precise, consistent rate. Unlike pendulums, quartz was resistant to temperature changes, gravity variations, and mechanical wear. Quartz clocks didn't just improve accuracy, they redefined it. Seconds became smaller. Errors shrank to fractions of a second per day. Entire industries depended on this stability. But humans didn't stop there. They asked a terrifying question: what if time itself could be measured at the atomic level? Atoms vibrate too, and unlike physical objects, atomic vibrations are governed by fundamental laws of physics, identical everywhere in the universe. This led to the creation of the atomic clock. Instead of counting gears or swings, atomic clocks measure the oscillations of atoms, typically cesium, as they change energy states. These oscillations are so regular that atomic clocks lose less than a second over millions of years. For the first time, timekeeping escaped Earth. Gravity, temperature, and mechanical imperfections no longer mattered. Time became universal. This precision transformed everything. GPS systems rely on atomic clocks. Without them, navigation errors would grow rapidly. Financial markets synchronize trades to atomic time. Communication networks depend on nanosecond accuracy. Modern civilization hums in rhythm with invisible vibrations. Yet this raises a strange realization. Time, once tied to the sun and stars, now lives inside laboratories. Humans no longer look up to know the hour. They consult machines that listen to atoms. And even atomic time has limits. Einstein's theories revealed something unsettling. Time is not absolute. It stretches and compresses depending on speed and gravity. Clocks at higher altitudes tick faster. Satellites experience time differently than Earth-bound systems. To keep GPS accurate, engineers must correct for relativistic time distortion. Time itself bends. So modern timekeeping isn't just measurement, it's negotiation, a continuous adjustment between physics, motion, and human agreement. This leads to a deeper question. If time can stretch, if it can slow, if it changes depending on perspective, what exactly are we measuring? Ancient civilizations believed time was cyclical, repeating endlessly. Early mechanical clocks treated time as linear and segmented. Modern physics suggests time is something stranger entirely, not a river, not a wheel, but a dimension intertwined with space itself. And yet, despite all this complexity, we still organize our lives with simple numbers. Hours, minutes, seconds, the same units ancient people invented by watching shadows move across stone. We've traveled far, but we're still counting the same thing. In the final batch, we'll step back and reflect how time measurement changed human consciousness, what we gained, what we lost, and why, even with perfect clocks, time still feels like it's slipping away. For most of human history, time was something you felt, not something you tracked. You woke with light. You rested with darkness. Life moved in seasons, not minutes. Time was shared. No one was late when the sun was late. No one was early when winter arrived too soon. But the moment humans began measuring time precisely, something changed inside us. Time stopped being a background rhythm and became a resource, something that could be saved, wasted, lost. Mechanical clocks trained people to obey schedules instead of nature. Factories demanded punctuality. Schools rang bells. Workdays were divided into identical units, regardless of energy, weather, or mood. Time became standardized. And with that standardization came power. Whoever controlled the clock controlled labor, controlled transportation, controlled coordination across cities and nations. Timekeeping helped build modern civilization, but it also reshaped human consciousness. We began to experience time as pressure, a ticking reminder that moments were disappearing. Ancient people didn't run out of time. They ran out of daylight, or warmth, or harvest. Those were tangible limits. Modern time is abstract. You can lose an hour without seeing it go. And yet, even with atomic clocks measuring billionths of a second, our experience of time remains deeply subjective. An hour can feel endless in boredom or vanish in joy. Grief slows time. Fear distorts it. Love suspends it. No clock can measure that. Physics tells us time bends with gravity and speed. Biology tells us time bends with age. Psychology tells us time bends with emotion. Time isn't one thing. It's many. The more precisely we measure time, the more we realize it refuses to be fully captured. Ancient tools, shadows, stars, water, tied time to the universe. Modern tools isolate time into numbers detached from experience. Neither is wrong. They simply reflect different relationships with existence. The sun doesn't hurry. The atom doesn't care. Only humans feel rushed. So perhaps the true story of time measurement isn't about better tools. It's about control. At first, humans tried to understand time. Then they tried to organize it. Then they tried to dominate it. But time never belonged to us. We only borrowed ways to describe its passing. And despite all our precision, every human still faces the same truth. Time moves forward, memory moves backward, and the present is always slipping between them. Before clocks, time was part of the world. After clocks, time became part of us, measured, counted, felt. And no matter how accurate our devices become, the most important moments will always be the ones that escape measurement entirely.